Hello folks, Mr. Wee here again to help you out with one more problem for the night. It's going to be 8A, okay? So if you need help with 8A and any of the problems below, you can follow the format generally of how we're going to figure out for A, okay? So guess what? The worksheet's still mcat, so we're always going to use the worksheet, or use the formula for this worksheet, Q equals mcat. Okay, so let's start with what we know so far. Let's try to dissect everything. Okay, so first I always like to say, or I always like to write the equation. Okay, so it's Q equals MC delta T, or mcat. Okay, let me see if I could focus in on that a little bit. Okay, so that's Q mcat. Now let's try to see if we have all these variables here. Okay, so let's see if I have a heat. Do I have a heat present? Okay, do I have a heat present? Let's see, 50 grams, it's not a heat. 80 degrees Celsius, it's not a heat. Oh, joules, wait a minute, is that energy? Heat isn't energy. Is that energy? Yes, it is. And by the way, again, this is a Q, not a G. I'm sorry, I write my Q's weird, okay? I apologize. Okay, so that's 100 joules. I have 100 joules. Okay, so that means in this reaction, there's 100 joules of heat being transferred. Let's see how. It's being absorbed, okay? So if you're absorbing in heat energy, okay, it's going to be a positive value, okay? If you release it though and you lose heat, it's going to be negative, okay? But in this case, we absorbed heat, so it's going to be positive, okay? So please just keep in mind that that's positive, right? It's good practice to do that. See if we have a mass. Do we have a piece of gold? Oh, okay, we have a piece of gold, but how much does it weigh? Oh, yes, we do. 50 grams. So there is a mass, okay? 50 grams, okay? So it's saying that 50 grams of gold, right, somehow absorbed 100 degrees, or I'm sorry, 100 joules of energy, okay? How about a specific heat? Do we have a specific heat, a characteristic of gold on here? What? We have the C of gold. Look at that. Okay, the specific heat of gold, not literally like a C, okay? But it's going to be 0. What does that say? 129 joules over, let's see, G degree C, okay? So again, what that means as a review, it means it takes this much energy. It takes approximately 0.129 joules of energy, okay, to increase 1 gram of gold by 1 degree Celsius. You don't see the number of ones in there, but if there are no numbers, you always presume that there's a 1 in there, okay? Kind of like when you do, sorry about this. Sorry, when you do like 1x plus 2, normally in math, you don't write the 1 there. You just write x plus 2, and you automatically know there's a 1 in front. Same here, okay? So it takes 0.129 joules of energy to increase 1 gram of gold by 1 degree Celsius. And that's just for gold, okay? Because we're looking for specific heat of gold. Anyways, let's get back to the problem. Okay, let's see. Do we have a delta T? Wait a minute. That's where things are a little tricky, because I have a temperature here, right? I have 80 degrees, that's great. But don't get that confused. That is not your delta T. That is not a change in energy. It just says your piece of gold was originally at 80 degrees. So you know what that is? Technically, because it was originally at 80 degrees, that's my T initial. That's what my temperature was, okay? Because if you remember, your delta T is technically a final temperature minus a initial temperature. It's just the change in temperature. How much did the temperature change? That's telling me how much it was before, which is my T initial, okay? I don't know what the change in temperature was, okay? That's what we're trying to solve for, right? Or actually, technically, we're trying to figure out the final temperature. We're actually trying to figure out the T of F, okay? But to do that, let's figure out just the delta T, right? Because our equation only has delta T in it. It doesn't have TF, it has delta T, okay? So let's go ahead and just plug in our stuff. We have Q, that's a Q, is equal to mcat, right? We know that. So let's plug in our stuff. We have 100, let's see, 100.0 joules. Oh, my phone is getting very hot, okay. I have a mass, 50.0 grams, okay. I have a C, so I'm going to put in parentheses for multiplication, okay, because I don't want to write the multiplication sign. I don't know why, I just don't want to do that. And I don't have a delta T. That's what I'm solving for, okay? So that's what I have. I just plugged in the M's and the C's, the Q's, and I don't have technically I don't have a delta t. I have a ti, but I do not have a delta t. Okay, so to get delta t by itself, just to figure that out, okay, I have to divide all the numbers in front of it that are being multiplied to delta t. Okay, 0.129. So guess what? 50 over 50, because every number is being multiplied on the top and the bottom, these are going to cancel out. The 0.129 is being divided by 0. That cancels out. But whatever we do to one side of the equation sign, I must do to the other. So that means I have to divide this side by 50 grams. Let's focus on that, okay? 50 grams and 0.129. So I got a fancier calculator than last time. I know it's kind of weird what you just saw. So I got a fancier calculator this time, okay? So let's just do this. I can't clear everything. Okay, so here's what I'm going to do. Okay, it says 100 divided by 50 and 0.129. Okay, so here's what I'm going to do. I'm going to do 100. Got it? No, I'll put the 0.0. You don't have to, but I did for the calculator at least. I'm going to divide it by, and I'm going to go fancy. If I want to put everything on the bottom being multiplied to each other, I'm going to put, let's see, what was the bottom numbers? It is 50 and 0.129, so 50 times 0.129. And notice everything that's being multiplied on the bottom is in parentheses and being divided by, okay? Everything, the 50 and the 1.29 or 0.129 are in this parentheses, so that way the 100 is being divided by all of that guy, both of these guys being multiplied to each other, okay? I press enter, boom, okay? 15 point, let's say 5. So I have a delta t, so I'm solving for my delta t. I have, what is it? 15.5 degrees Celsius, okay? I'll box that, but I'm not technically finished, okay? Great, I have a delta t, I have a change in t. Is the question asking for a change in temperature? Does it say what is the change in temperature? It does not. It says what is the final temperature? What is the final temperature? Okay, so what I'm going to do is I'm going to use this original guy right here, okay? I'm going to go one more step. Delta t is equal to TF minus TI. Here's what I'm trying to look for. It's asking for the final temperature, not the change in temperature, but the final temperature, okay? I know that this whole reaction had a change in temperature of 15.5 degrees. I don't know what the TF is, but was I given information about what the temperature was originally? Oh yes, I was. 80 degrees. So the reaction technically started at 80 degrees. We want to know where it ends at, okay? Because I know it changed by 15.5 degrees. I just don't know where it ends at officially, okay? So here's the equation. What do I do now to figure out TF? Okay, hopefully you guys have noticed I just get rid of the 80 on this side. Boom. And then whatever I do once, I have to do the other side. So I'm going to add 80. I don't know how much battery life I have left, so I got to rush this. So 15.5 plus 80, if you can do that in your head, that's 95.5, okay, degrees Celsius equal to the T of F. That is your final temperature. That is your final temperature. 95.5 degrees Celsius is your T of F. Okay, that is your final answer. But hold on, if you need to go back and just check for significant digits, I mean, we're pretty much done. We just got to check if it has the correct number of significant digits. Go all the way to the back. I don't like to do significant digits until the very end. So let's just go only to the numbers that we started with, okay? How many significant digits does the Q have? It has 4. I'm just going to say it has 4 significant digits. M has 1, 2, 3, remember? Because there's a decimal that makes these zeros significant, okay? So that's 3 significant digits. C has, okay, that 0, the leading 0. Only the 0 is way in the front, okay, which it is. Even if there's a decimal point, are not significant. So 1, 2, 3. These are significant, okay? And that's it. So that's all the numbers I started with, and I only count the numbers I started with. That's the lowest number of significant digits, 3. So my answer should only have 3 significant digits, which it does. So I don't need to do anything to it, okay? If you still have any trouble and you have any questions, come and see me right away tomorrow during lunch, okay? You don't have to finish the worksheet. Hey, still do it though, okay? You kids still do it, okay? But if you need more time and help, okay, and you only have a few more problems to finish that you want to wait on me, or at least you tried and you're struggling with, come and see me tomorrow for lunch, okay? I won't help you if there's nothing on the paper, though, okay? So you still need to try, okay? All right, you guys have a good one.